This is it, our final topic of the course. Last one. Here I have two lengths. I can make a ratio of their lengths, 1 to 3. Then I can take those lengths and create polygons out of them. So I took 3, made a rectangle that's 3 by 2, took the 9, made a rectangle 9 by 6. These figures are similar. 3 to 9 reduces to 1/3, 2 to 6 reduces to 1/3. Two similar figures. The area of the left polygon is 6. Area of the right polygon is 54. Make a ratio of those, and we get 1/9, which is our scale factor squared. That's from our last unit. Two similar polygons or two similar two-dimensional shapes have an area ratio that is simply their scale factor squared. That's true with solids as well, or at least we hope it is. So here are two solids. I can find the surface area of each. This shape has our 6. This shape has an area of 8. This has an area of 24. Add all those up, I get a surface area of 38. But because we have to double it to account for the two, or to account for the other that are missing, for example, there's a back that's missing, there's another side here, and there's a bottom. You get a total area of 76. Here I get an area of 72, 54, 108. If I add those together, 234, doubled, 468. Something doesn't look right. Something is off. Oh, maybe not. 3 by... Whoa, that's incorrect. That should be 12. That should be 12. That should be 26. That should be 52. Let's try that again. Much better. Area ratio of the two solids is the same as the area ratio of two polygons. It's an area ratio. These are similar solids. They're in a ratio of 1 to 3 all the way around. They should have that same ratio, that same scale factor squared ratio. Now let's take a look at their volumes. The volume of this prism, base area times its height, the volume of that prism is going to be 24. The volume of this prism, base area times its height, 648. We take a ratio, 24 to 648. That reduces down to 1/27. 1/27 is our original scale factor cubed, making for a very nice relationship all the way around. Going back to the beginning, we took our original scale factor 1 to 3, squared it to get an area ratio. Now we cube it to get a volume ratio. The volume ratio between two similar solids is simply our scale factor cubed. It's our scale factor cubed. And this is a way that manufacturers in particular and architects can make models very, very easily when you have objects that don't have nice volume formulas. For example, you want to have a container that holds X amount of volume. So when you do small scale testing, you can quickly and easily determine what the volume of the model is going to be, or vice versa. We have the model, we want to scale it up to a much larger thing. How much volume is that larger thing going to carry? So we simply take our original scale factor, cube it, and we have an answer quickly rather than trying to calculate something that's much more complicated. Here we have two solids. Solid A, solid B. We have their heights. We know the surface area of solid A. We know the volume of solid B. We know the solids are similar. Find B's surface area. Find A's volume. I guarantee you, a question like this will be on your last graded work. And I guarantee you, if you don't use the correct ratio, you will not get the answer correct. You cannot use 4 to 11 if you're finding an area or a volume. You cannot use it. You have to use the appropriate ratio. If you are using area, if you're finding area, you have to square it. If you are finding volume, you will have to cube it. If you don't do that, don't expect any partial credit because you are not starting on the right track. Let's start with solid B's surface area. Because we are using an area, we're finding an area, we have to square our scale factor. So here I have the area ratio, solid A to solid B. Square the scale factor. A's surface area, 123 square feet. B's surface area, don't know. And it does say to the nearest tenth. By now we know how to solve these, so you don't need me to show you the way there. Approximately 930.2 square feet. Now to find A's volume, we have to cube our scale factor. So we do not use 4/11ths, but we cube it to get a volume ratio. Don't know A's volume. B's volume, 814. And this will be approximately 39.1 cubic feet. Don't forget the labels. There's a label in the problem. There must be a label in your answer. Area ratio to find surface area. Volume ratio to find volume.